on the net. I will show you. Hey, what is going on here? Okay, so this is the sensor. This brand. It's metal. Okay. So I found a sensor. It's a made in Germany sensor. It costs 360. Its sensor costs 360. Okay. The old sensor was 70 ringgit, and we have to buy 20 per week. This one, knowing that this one is 20 per week, I thought this one buy 2 extra lah. But the total budget for me was 16,000 to change all the sensor. So that time company was also having problem. So I had to, this is what you got to do next time when you are engineers. I had to go and stand in front of the whole management team, explain why I need to change it and how it can benefit the company along essay lah, all the cost benefit analysis, why it could be better. Of course, I don't know, but my suggestion is that if you have metal, you can hose clip it, wear it as tight as you want, and nothing happened to the sensor. Okay, so they finally decided to give me 16,000. Okay, the management, even though the company was in trouble at that time. So they gave me 16,000. I changed all the sensor. I buy 2 extra. Now 2 extra I keep on my table, okay, in case one fell. I left the factory 10 years later. The 2 extra are still on my table. Okay, imagine that this is 20 per week. This one, after 10 years, not even one fell. I just want it to be a metal sensor so I can hose clip it very tight so it don't move out of position, so it don't damage the product. But I didn't realize when you spend a bit extra from 70 go to 360, the quality is also so much better. Okay, so there are some products you get to know when you go to work. There are some products that just don't fail at all. Okay, it just doesn't fail once you have a proper sensor. Okay. Okay. So the Turk sensor, how do you pronounce that word? T-U-R-C-K. Okay. The Turk sensor is a superior sensor. I've seen other things like you know, this cylinder. To control this cylinder, what we do, because our control is all by PLC, right? So PLC is electrical, so you need to convert it to A, because this one is A, right? So you convert the electrical signals to A signals. What we use is okay, electro-pneumatic valves. Okay, the same thing now. The brand is Humphrey. All this you can put in your assignment now. Okay, I'm giving you the real brand. This one, some of them 30 years, never fail. And then we got some brand, Japan brand, SMC. Okay. Okay. Humphrey, we use it for 30 years. I never seen one fail basically my whole time I worked there, and then till now, the factory is still there. It never failed. SMC is quite a good Japanese brand, but 6 months it failed. Okay, so there are some brands that they are designed not to fail at all. Okay, you won't see it in a local market. Anything that you buy, like me, I grew up in Kuching. Everything I buy, I know after a short while it failed. Okay, only when I went to US, then I found, hey, your plier never fail at all. Yeah, I'm surprised to see here you buy a plier, sometimes the plastic handle will get deteriorate after a while. Sometimes totally gone. The plastic somehow just melt. Okay, but when you get a good plier in US, I of course in US I have no money, so I buy from the second hand. It's quite common in US lah. They have like on Sunday something they got. We got our Sunday market. Sunday market, one portion people sell used tools. I go and buy some tools, cheap, quite cheap, but it lasts forever. Okay, I don't know about now. I don't know what's the situation in the US now. I left quite long ago, so that's the first time I saw things that never fail. So that's why when I came back to Kuching, I go and look for shops that can sell that kind of quality. So right now in Kuching, I only go to 1 or 2 shops. Electrical, only 1 shop. I already banned all the other electrical shops. I only go to 1 electrical shop, Crown Engineering. And then instruments, you must go to 1 Bintulu shop. I think some of you from Bintulu. You must go to this shop. Let me show you. Okay, here, this shop. Okay, the whole Sarawak, this is the best instrument shop. That means I'm talking about multimeters and all the different testers. You want to buy, you buy from this shop. Okay, because this shop is supplier for oil and gas, so they only sell genuine. They sell the palsu like almost every other shop in Sarawak. The oil and gas will ban that. So that's why you want trusted instruments, you come here. Where is this? I think they call it Park City, Bintulu, I'm not sure. But next to it is Laksa House, one of the most famous Laksa shop in Cebu. I think they sell only Laksa, if I'm not mistaken. I think I was there before I was a vegetarian. I've been vegetarian for 22 years, 23 years. Before that, I went there. Of course, they don't have anything vegetarian in that shop. Laksa House, I think they sell only Laksa. Okay. So this guy is one of the, mistaken, he's one of the Cebu councillor. Yeah, one of the Cebu councillors. Next door is a clinic, I believe. His wife clinic. His wife is a doctor. Okay. So that's why for me, electrical, I only go to the shop like Crown Engineering Kuching for all electrical components. Not electronics. I think electronic shop, for me, the trusted electronic supplier is this one. This one. Okay. This one really is safe. I give you another story. Unimas, they had a problem because they built a micro hydro. Okay. So the micro hydro failed. but Unimas got a contract, the government contract lah, federal government contract to build it, and then they asked this company to build it, and then in the end it failed. So Unimas and the company, they're fighting each other. I went, they asked me to go for a meeting. Wow, very loud noise. They're screwing out each other, very angry, because both quite powerful politically also. Okay. One is SUPP, top guy, and then Unimas is, state government, and federal government. So I don't know. So they both don't want to lose lah. They say you are a problem. The other guys say I'm a problem. I mean, they blame each other lah. And then one lecturer, I think he's a civil engineering lecturer. I think he's kind of high up in among projects lah. He suggested, okay, let's send Prashobh, because Prashobh got industrial experience. Maybe he can repair it. So they sent me. After a lot of lecturers went there, so many lecturers went there and came back. It's not working. They say it's totally failed project. So they sent me there, and then I got it working lah. Actually, 2 times. First time worked, and then not so good, and then one more time I got it working. So what my suspicion is, you see how it works is you got a triac with 3 legs. So the generator will go to this leg. This from the power will go here and then go to Kampong. And then the brain will control the center gate. The center gate is the gate. Okay. So the brain, if the water is too strong, the rasa, what they do is the gate will open the connection between here and here. So it go to this leg goes to the resistor bank. They call it balas, to dump the power. Okay, to dump more power, because the water is too fast, right? So when the water is too fast, there's more power. So you have to dump that extra power to the ballast. Okay, so that's how it works. And then this triac, I checked the amp going inside, like 20 amp. Wow, you all do some electronics. Ampere in electronics like point something amp. So 20 amp. I never seen an electronic handle so high amp. So I thought this must be the problem. And then I checked the brand. I take a photo of it, check internet, what brand is this? Yeah, Alang website. I mean, like, they cannot even make a website. How can they make a chip? A triac. So I went to RS component. I found a triac with the correct ampere capability in current. I bought it. It's quite expensive lah. I think maybe like 80 ringgit each. So I buy 6 of them, and then I install it, and it works till now. It's like 5-6 years, it's still working. So you see, when you get from people like this, they're high quality. You see, normally they are trusted brands, trusted. They sell only their trusted things lah. Okay, so that's why a part of engineering is to know who your supplier is. Okay, you cannot, if you are a contractor, you cannot say, hey, it failed. You cannot say, hey, it's not my problem. The supplier sell this. I go and buy the component from this guy. He supply me things that fail. It's you as an engineer must know who is a good one. That's the job of an engineer. Okay, locally who is a good one, internationally who is a good one. Sometimes they change. Some good ones become bad locally as well as internationally. Something wrong in the company somehow, you become bad. Okay, you got to switch to another company. Okay, so the job of engineer is to find out who are the good ones. Okay, RS component was around since I was in Form 5. I think Form 5, Form 6, we had to do some projects. Those days all using letters, no internet. So we have to tick books. They send you the tick catalog book of what component they have, and then we got to search what component is correct and buy everything using a letter. Okay. So I think it's a If I'm not mistaken, it's a British company. That's why they were here since the beginning of Malaysia, because we were a British colony. Okay. Okay. So the first assignment is about the power system. So the power system, it starts from Bakun. Let me show you some slides. Okay. Okay, this is how it's generated in Bakun. Okay. So the center is actually an electromagnet. They can use a permanent magnet, but permanent magnet cannot stand heat. You go and buy a magnet from a store, say a cheap store, you go and buy a magnet, you go and heat it up, you turn back to iron. Okay? The difference between iron and magnet is this. Okay, so in iron, there are small regions called domains. Okay? Inside the domain, the electron can be flowing clockwise or anti-clockwise. So overall, it is not magnetic because some are clockwise, some are anti-clockwise. Okay, so when you get a piece of iron, say this is a piece of iron, you swipe with a magnet. What happens is all these electrons in the domain start flowing in the same direction. Okay, so that's how iron become magnet. So magnet is almost all iron because there's so much iron on Earth. Only magnetic metals have this thing. Okay, domains, and there are very few magnetic materials. Iron is the main one. Okay, and then there are a few others, but generally is not used. So you can say almost every magnet you see on Earth is iron. Okay? They tend to put a bit of other materials just to make it stronger. Okay. So once it becomes a magnet, you want to turn it back to iron. You just heat it up. You burn it. You turn it back to iron, with some clockwise, some anti-clockwise. Okay. So for resistivity, number one, okay, for resistivity, Number one is silver, number two copper, number three is gold. But for permeability, which is the same thing as conductivity for electromagnetic fields, okay? So how electromagnetic field can pass through a material is permeability. It is analogous to conductivity, okay? So for permeability, number one is iron. And you don't even talk about number two, because number two is so far away. I'll give you an example. Iron is 1, copper is 1000, so far away. This one, all they're very close to each other. Okay, this one all very close to each other, but this one, number two, like copper, is 1000. It's so far away. This one is the best is iron. Okay, so paper, copper, zinc, wood, they are all about 1000. Okay, iron number one. The value is 1 in permeability. So that's why they use the electromagnet in the center here. Okay, they use electromagnet. Okay, they don't use a permanent. They are using permanent magnet for higher and higher megawatt, but not for Cisco standard. Cisco standard is very large. Very large. They have to use electromagnet. So the only way for you to give current to something that's turning, because the rotor is turning, right? This is rotor. Okay. So this is a rotor and this is a stator. Okay. So the only way to give power to this is using carbon brush. Okay. All of you have seen carbon brush, huh? You all saw carbon brush before? Okay, let me try to find a carbon brush. Okay, this is carbon brush. Okay, you can see, right? Okay, that's a carbon brush. This is a high quality one. Okay, this is the connection, and that's a carbon brush. Okay, so carbon brush is used to send power to something that's turning. You cannot have metal joined to a metal. Okay, because you'll scratch the metal, right? So you use a carbon brush like this. It's a smooth material. So you send power to a rotating rotor. Okay? So all generators must have carbon brush. That means all Cisco generators have carbon brush. Okay. So Cisco also didn't know this. I thought a group of Cisco power station people, one whole class of power station people, and then they change the carbon brush every month. I told them, "Are you sure you need to change that? My drill, Hitachi drill, 20 years never changed carbon brush." So one guy actually did research at the end of that was a diploma class. He found out there's a German company that supplies carbon brush that lasts pretty much forever. Okay, it's true. In my factory, Western Digital, the carbon brush never failed. Okay, so that's why you have to be very careful when you buy this thing. There are some people who sell you this thing for 1 ringgit 50 cent. Hardware store will sell you 1 ringgit 50 cent. But it's so much different from the original like Hitachi. And this one I got it from DeWalt. Okay, DeWalt. This for my bigger drill, DeWalt drill. After a long time, it failed, so I had to buy a new one. So there's an original DeWalt seller in Kuching, so that's why I get it from him lah. If you get original, it can last 20 years or even more. You get alang-alang 1.50 ringgit, 1 week, it'll fail. Okay. Actually, carbon brush is actually graphite. Graphite is your pencil lead, you know, your pencil lead is graphite. It's the same thing. Okay. So this and this is basically the same thing. Okay. But some people actually use this. They don't use the one that is developed over ages. This is like 150 years old technology. The good companies, they develop, they carry on the development till now. Okay, so that's why you get a very high-end top company like Hitachi, DeWalt. Okay, they know how to make carbon brush. That means the technology carry on from 150 years old. Okay, the new company sometimes, okay, let's start making a carbon brush. You're going to take pencil, lead, and make it. Okay, it lasts 2 weeks. Okay, I don't know exactly how. Of course, it's a company secret. They don't tell you how they make it last so long. Probably they put some. I heard there's some metal inside there, mixed with the graphite. Okay. Okay. The basic idea of carbon brush is it need to be smooth and don't scratch the rotor. So obviously, if you can enclose a copper, a tiny micro inch copper with surrounded by graphite, it's smooth enough. Okay, something like that, lah. Okay. Okay. So. Okay, so this is the this is energized by a carbon brush. So this become a magnet. So when the magnet passes this one, it produces a current inside here. Actually, there's 3 coils inside here in this rotor: red, yellow, blue. So this is the clockwise red, this anti-clockwise of the same red. This and this are the same wire. If you follow the wires on the exterior here, you find out that this and this is the same, this and this are the same wire, this and this are the same wire. Okay. So they gulong clockwise here, they gulong anti-clockwise here, gulong clockwise here, gulong anti-clockwise here, gulong clockwise here, anti-clockwise here. Okay. And the other end, what happens? Other end, they just roll it up. Okay. Okay. So the other end, they just put 3. Okay. They just gulong. Okay. That's called star point. Red, yellow, blue, you can join like that. Okay. So red, yellow, blue joining in electrical is not as serious as red, yellow join. I can tell you the difference. In my school, I have a school in Kuching. If you just touch red, yellow, the explosion, because my school is like 90 feet lengthwise by 30 feet, the whole 90 feet can hear. But if like this, even the person next door, the person next to me also cannot hear. Okay. Why? Because this is 240, 240, 240, but it's red, yellow, blue, but all 240. Okay. So here is 240, here is 0. 240 is 0. So it's only a 240 shot. Whereas like this, it is considered 415 volts. Okay. So if you look at it, what is 240 and 415? I know you are a senior student, but I see a lot of people who don't know this. I teach you also lah. Okay. Okay. You see, the AC, the 240 is somewhere in the middle of nowhere. Okay. The peak, which is what the meter can measure, is 339. So why you get 240 here? Okay. Okay, I'll send you all this later lah. Okay. I told you, I messaged you in the WhatsApp group that I'm going to Sri Aman early morning and then come back for your class. I decided that's too risky because it's 2 hours away. I missed my time a bit. I might be late for class, so I decided to go to Sri Aman, 2 hours away drive right after this class finish. So I'll send you these notes probably tonight when I come back from Sri Aman. Okay, so how it works is the meter can only measure the peak, and the peak is 339. Okay, 339 times 0.707 is 240. Okay, so why did this happen? See, I'm telling you the basics so you understand the whole system properly. You see, the first system was DC. Okay, the first system was DC. Edison's system was DC, so it was a very big thriving business. And then Tesla is from Croatia. Okay? So he studied in Austria. Austria is basically German people. Okay? Then he only studied 1 year because after 1 year, he got straight A's from kindergarten all the way to first year electrical engineering. Okay, and then he quit because at the end of first year he had a quarrel with one lecturer. Lecturer was wrong lah. He was right as usual, but lecturer was wrong. So he had a quarrel with a lecturer and then he quit. So he went to work for Edison's company in Paris, France. From there, the boss wrote a letter to Edison in New York. I know two very smart guys. One is you, and one is this new worker I just hired. Okay, Tesla is much younger than Edison now. So Edison said, okay, send him over. Okay, so he went to New York, and from there, Tesla developed the whole electrical system. So he worked for Edison for a short while because Edison's system was all DC. See, generators can only generate AC. So they use carbon brush to make it DC. Okay? Generator can only produce the AC. So they use a carbon brush to get this one, and then they arrange the carbon brush properly. Next step is like that. It's wavy. It's bumping DC, but still DC. As long as above the zero is DC. AC means go bottom and top of the zero. Okay. So it can be anywhere as long as on top. Even if it is a sine wave on top, it's still DC. Okay. So when they heat water, because the initial use of electricity was actually to heat water. Yeah, the story is New York was getting taller. The buildings were getting taller. Okay. In the old days, New York is a cold place. They need fireplace. So in a single story house, you put a fireplace, some accident, no problem. They can run away. The house burn. What to do? Okay. But when a multi-story house, when one fireplace burn, a lot of people die. Okay. So the mayor of New York said, go to Edison, because Edison's first business was an invention factory. Okay? He go to people, ask what you want me to invent. So he and his team. His team are not the smartest guy, not the one who has a good degree and all that, because he himself didn't go to study. He went to kindergarten 3 months and then he quit because he asked too many questions to a teacher. Teacher got angry with him. Okay, why? The teacher got angry, so he went home, told the mother. The mother said, "Okay, you don't need to study. I teach you." So the mother taught him, and then but you cannot say he's not educated because he is self-educated. He go to library, he read every book. Okay, so. So he started his first company. He's a smart guy, lah. Okay, but because I've been in electrical all my life, I'm 57 now. I'm reading about these two people a lot. He's very smart. Okay, for a human being, he's smart. But Tesla, I believe he's not even human. I mean, what he did is beyond human. So I don't know. I suspect he's not even human. Edison is very much human. You know, he got his own failings, his own weakness, human weakness. Okay, but Tesla, he invented the whole AC system. The induction motor, which is the main motor used in worldwide, it used about industrial energy, which is the main energy used worldwide. It's about 70%, almost 70% of the power generated for industry is used by induction motors. Okay, and that induction motor is designed by Tesla, invented by Tesla. Your kipas, your home fan, is a Tesla's induction motor. Your home aircon is an induction motor. Okay, so every house has something like at least 5, 6, 7, or like my house, I think I got, I don't know, 20, 30 induction motors in my house. Okay, the Tesla electric car is an induction motor. Okay, Tesla is not the Tesla scientist cucu punya company. Tesla didn't get married. Okay, so I think he had a girlfriend, but he didn't get married. I don't know why. I didn't read so much about that. He never got married, so he don't have any grandchildren. Okay, so the Tesla car company is they just want to hormat, give hormat to the scientists, so they put the name Tesla as a Tesla Motor Company. Okay, so the initial use of electricity was to heat water. Why is this? You see, they give Edison a contract to find a solution to the fireplace burning. Okay, so he said, okay, we use electricity to heat up water like this. Okay, to heat up water. Okay, heat up water, and then he was using DC to heat up water. And then you go to every room. In every room, there will be a spiral of pipes. When I was studying in USA, that thing is still in my room. A spiral, but not used lah, because we are so poor students. I went to US without money. We can't even afford heat. So we wear a big jacket in the house and survive somehow. Okay. So there's spiral of pipes. Because to pay for heat is a lot of money. So we cannot afford to pay for heat. So there's spiral of pipes in the room. So that spiral of pipes will carry the hot water, and that replaces the fireplace. Okay, so that's a perfect solution. So the mayor of New York, wajib, everyone must use this method, cannot use the fireplace anymore. Too many hazards with fireplace. So his business grew worldwide. Every cold country need his system. So he go to every country and install his DC electric heater system. Yeah, became very big business. That's why his company is in Paris. And normally in those days, America was cowboy, orang pandai, okay, and then the smart people are in Europe. Okay, so no, always is you want technology, you go to Europe to get technology, and never the other way around. But it's the first time the other way around. Edison's company go to Paris. Okay, you won't go to England because England still treat America as a runaway gangster, so need to kill them somehow. But you go to Paris, okay, the French are a bit more cooperative with the Americans. So they were doing this heating, and then Tesla came. Tesla, when he first went to Edison, he introduced the induction motor to Edison. Just came over from Paris to New York. He introduced the induction motor. So Edison looked at it. He said, "Son, you forget something. Where's the carbon brush?" Because every motor in those days need carbon brush. This one, no carbon brush. Because you see the rotor is three-phase, right? Red, yellow, blue. Okay. So this one first, and then this one, and then this one. So you can just turn. You pull the rotor because the magnets. This one first, this one second, this one third. So you just turn around. So so you don't need carbon brush. So Edison said, "But my system is DC." Edison's word was, "You want me to destroy my whole system for this stupid motor of yours?" You know, at that time, one small motor is induction motor. But that's what's happening now. The whole DC system was destroyed, and now AC is being used. Why? Okay, I'll show you why. Oh. Damn. Okay, this is the reason why. Okay, you see, most of power is coming from Bakun. Bakun Murum is practically powering the whole Sarawak. Okay, there used to be other power stations, but like Sibu, there's one big power station in Sibu, in Sungai Merah. They closed it down. Okay, and they're getting a power from Bakun. Okay, Bakun and Murum is just upstream a bit. Okay, so they produce at 11 kV and step up to 2005. Why they do that? You see, the power of the water coming down is VI. Okay, when you put the V very high, automatically the I goes down. When you put this I that is low inside the loss, power loss, basically the thing that makes the wire hot. Okay, make the wire red hot. Okay, that's I square R. Okay, I square R. So when you have a low I that you put inside this formula, the loss has become very small. So that's why our overhead lines, the big lines, you don't see them red. Okay, it's because of this. And why you can't do this with DC? Transformer cannot work with DC. You put a very big DC inside the primary of a transformer, come out nothing. Nothing comes out the other side. Okay. So how does transformer work? You see, you got a wire like this, magnet like this, FBI. I think you learned in school FBI. In school, they teach you this is force, magnetic field, current. That means this is north-south. This is the force, so it's like that. Okay? 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 Okay, like that. Okay? But what is happening here? See, this magnet got magnetic field. Okay? So when you go further, the magnetic field also further apart. So by the time, when it's like this, they want to see 1 only. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so I say this one is varying field density. Okay, the F, varying field. So F is still F lah, varying field density. Okay, in transformer, you got 2 coils. Okay. But this one has varying field density. Why? Because AC. So the field is 0, maximum, 0, maximum, 0, maximum. So varying field. So you got an F already. B you got because it's a solenoid. You got B, north south. So you got I in the secondary. So that's why you got current generation in the secondary. If you put DC here, what happened? There's no varying field density. So there's no I in the secondary. Okay. So that's why DC cannot work. If you want to have a DC system like UCDS, building 6, you need 1 generator. Building 7, another generator. Building 8, another generator. If you put all your power, one big generator in building 6, by the time you reach building 9, voltage drop. Okay, too far away. Okay, so that's why DC is a problem. That's why they changed to AC, because it can transmit over a huge country like the whole Sarawak, just from Bakun. Okay. So this is the basic system. Right? You use transformer. So why do the generator produce at 11 kV? I wrote this in my notes that I sent you. Why 11 kV? You know, why can't you just produce at 275? Because you're going to send out 275 anyway. So why you produce 11 kV? Because if your generator itself is 275 kV, the human cannot work inside the power station. It's too powerful. So every generating station is around 11 kV. 11 plus minus lah. Some can reach 15. Okay, 15 kV. Okay, but mostly it's around 11 kV. Okay, so that's why I don't know why that day I went for one ceramah by our former chief minister. He was saying, Adinan, he's giving a ceramah before the election here, so they invited me to go. So I was saying, hey, the people around this region got big power station here, but people next door no power. I don't agree with this. I don't know why no one did it, but this is 11 kV. The output of the transformer you can send to the kampong already. I don't know why they don't do that. I think it is, they're very nervous because this is the whole Sarawak power coming from here. They are nervous to do that modification. I don't know why they don't do it. But it's 11 kV. This is exactly what you send to your perumahan. You can send out these wires. Because the alasan now they give that these people have no power is because from 275 you want to step down to 11, it's 10 million ringgit transformer. Maybe only one long house. Okay, they say tak babaloy. Okay, 10 million just for one long house. Okay, but you don't need a 10 million. You can just send out from here. Outgoing of the power station straight to the kampong. Okay, I don't know why no one have done that yet. Okay. Okay. So what the government did is, I remember the one is Adinan. The kampong around here, they put solar panel. Solar panel after 2 years all rosak. It's standard in Sarawak. Solar panel after 2 years all rosak. Okay. I did a paper about this. Every solar farm after 2 years fail because solar is not meant for this country. We have too much cloud. Okay. Solar is best for a desert country where there's no rain. So you got sun every day at 7 o'clock, guarantee got energy, and then 7 p.m. no energy. They can predict this. Ours, intermittent is a big problem in power. You cannot be intermittent. You see, if you're talking about one long house, okay. What if you're talking about 1 big solar farm in Cebu? Okay. Tiba-tiba pukul 2 gelap habis hujan. No power. It can be as much as 70% of the power gone, or maybe even 80% of 1 gig is gone. How to back up 1 gig? 1 gig is very hard to back up, you know. You know why? To start a combustion engine power station, 1 hour. I call you start, 1 hour later you start. Okay? 1 hour only later they can give us the power. I call a gas turbine, like Bintulu is a gas turbine. I call them 45 minutes later only they give me the power. But the glove can be in a few minutes. Sometimes within 20 minutes, glove, Cebu glove. Okay, that is like 800 megawatt disappeared due to no sun. That's the problem with renewable energy. It's not practical at all. Okay? They say, oh, we can back it up with battery, but battery is too far away in technology. Okay? People say, no, battery is good. No, you go and really search the battery, current technology of battery is too far away. Okay? It's too expensive. One solar battery is 12,000 ringgit. Okay? Like Barrio, when we were doing the mini hydro in Barrio, next door, a few kilometers away, they're doing a solar farm, the largest solar farm in Sarawak. And then now, one of our lecturers tend to go there a lot. For the IT lecturer, Gary is an IT lecturer. He used to go to that Barrio solar farm. He said, I think 10 or 20% of the battery mati sudah. That's 700 battery. They got 700 batteries in there, and 10 or 20% mati. Yeah, say 10% lah. 10% of 700 is 70 batteries. 70 times 12,000 ringgit each. That's too much money. You know, it's 12,000 times 70 is how much already? Just 2 years later, okay? 70 times 12,000. That much money, in just 2 years, they got to come up with this extra money. 840,000 for 2 long house, 1 church, and 2 bungalows. Okay, they got a town also. So okay, but the load is so low, and every 2 years you got to come out with this money, 840,000. That's why renewable is not really practical at all in Sarawak. Yeah, we need to go back to old-fashioned system until someone come out with free energy, which Tesla already developed. Okay, Tesla already developed free energy, but it was hidden because Tesla, I don't know exactly how he did it, but it's something to do with the earth. There's some current in the earth, and also he talked about. He actually made a statement that it is from ether, like space. Okay, empty space is full of energy. Okay, he devised that because he was wondering if you look at this one. Okay, this one is corona discharge. So Tesla was working for Edison. His statement is here about the free energy. Okay, maybe you can print screen this if you want to know about free energy. Okay. His statement about how he made free energy is somewhere here, if you want to try to understand it. Okay, so he noticed his corona discharge on the wires. Because Edison had to use very high power because his power cannot go far, cannot step up, right? So he used very big generator just to go 2 kilometers away. Must be very big generator. Okay? So you throw a very big switch and suddenly you see this corona discharge, this purple light all over the wire. Okay, and then after a while, it will disappear. But if someone stands below the overhead line, this purple light will go to his body, go to his head, and kill him. Okay, so nobody dare to stand under the line. Okay, so the engineers in Edison's company were trying to fight this corona discharge using all sorts of methods, but Tesla was very interested in this. And what is this? He knows by the speed of it, it's traveling much faster than electrons. He knows electrons don't travel that fast. Okay, So he went to research. Later he became rich lah. He became rich, and then he moved to the other end of USA, and near the California side. You know, he was on the New York side. He moved to the near the California side, and he did research on this. And then he found out that this is actually energy from empty space, black space. He said black space is full of energy. Okay, so so he made a car. Actually, he made a tower first. Okay, imagine a world of free energy. Okay. Okay. So imagine a world of free energy. He made a tower to send energy up to this ionosphere. Ions means atoms with extra electrons or less electrons. But in the air, it's mostly extra electrons. All ions, you got paper, plastic, or air, that's ionized, are conductors. So there's a layer of conductors, one whole layer of conductors called the ionosphere. Okay, this is the ionosphere. So you send power up to ionosphere, and this is a conductor, so it just goes around, and then you have a house in Malaysia, you can tap the energy. You got a ship somewhere in Japan, you can tap the energy. So everything can run from this tower. Okay, so it's free energy. So the person who financed him to build this one is JP Morgan. JP Morgan went for a site visit. JP Morgan actually asked him to make communication. You know, the world all believe telecommunication were invented by Marconi. Actually, Marconi stole his patents. He already patented the whole telecommunication system, but from Tesla. So actually, Marconi just stole his invention. So the US right now recognize Tesla as the inventor of the telecommunication system. Okay, so Marconi is not the real inventor of telecommunications. So this telecommunication Tesla already do. Karang putih. He said this one can give free energy to the whole world plus telecommunication. Plus you can send pictures. That means you can have handphone that we have right now can send pictures and movies 100 or 120 years ago. Okay. If they allow his invention to be real. Okay. But you see what will happen? You have a car using his motor, which is an induction motor, Tesla car. Okay. You drive from Miri to Kuching, Kuching to Miri. You never need to put petrol, free energy. Okay. And induction motor, if you make it good, just like in Western Digital, there is an induction motor that's running older than you, continuously running. It never fails. Okay, you can make it good, it will just never fail. Okay, and then he also made free fertilizer, because what is fertilizer? Fertilizer is just nitrogen, but we use NH3 in Bitru's factory making NH3. Okay, NH3. Okay, we use NH3 to make fertilizer, but the plant only needs the nitrogen. But we cannot. Nitrogen is gaseous, so we cannot supply the farmers nitrogen. So we combine it with H3 and supply the farmers. Okay. So he made a machine, free energy machine. You chunko some earth, put inside the machine, come out fertilized, full of nitrogen. The plant only need the nitrogen. So is free fertilizer. Okay? Imagine you drive from Kuching, you stop somewhere to makan. Makan also very cheap because free fertilizer. Stop in Cebu to makan, the food very cheap, and your car never need petrol. It's a perfect world. Yeah, but you know what's going to happen? Petronas mati. Don't need petrol, so Petronas mati. Don't need electricity because electricity is free, so Sesco mati. ABF in Bintulu making this one mati. Okay, basically all the big factories in Bintulu mati. Okay, so rich people cannot make money. Okay, maybe the press metal still alive lah, because they are not involved in this. But the whole Shell, Petronas, Shell MDS maybe still can survive. They're making plastics and all those other stuff. But Petronas gas plant will have to close down. The ABF will have to close down. The cable companies, Universal Cable, have to close down. So basically, the rich man cannot make money. The poor people will be very happy. They can live a very happy life. No need to spend much money, can survive. But the rich people of the world of those days are similar to rich people of the world today. They don't like that one. They want to be the boss, everyone hamba, they like that way. From the ancient time, it's been like that, like the king and all the hamba around them. Okay. So they don't like the upside down world where everyone equal. They don't like that one. Okay. So the rich man sabotaged Tesla's idea, and now we are having the world we are having now. Okay. Hopefully, all this will come out. I have hope within my lifetime they will release all these technologies, and then the world will be a totally different place. Okay, with free energy, imagine a ship can go sailing. I mean, not ship can go all over the ocean. It never need to refuel. The engine will never break down because the induction motor is so simple. It's just a coil around a rotor. It can never fail. Yes, there's proof. I've seen it in Western Digital Kuching. There's one motor that's running longer than your lifetime, and it's nothing happened to it. Okay, so if you make it good, it will just last forever, pretty much. And most people don't know about this because I'm a CIDB lecturer for contractors, so I go all over Sarawak to teach them. And one time I was in Miri. This guy said he changed motors every 6 months. I said, why? You don't have a good motor. My Western Digital Kuching never fail. I said, boss say like that, I just do lah. Most people don't know. I talk to all the contractors, they don't know that there's such thing as a motor that can last forever. Okay. If you make it good, it just lasts forever, pretty much. Okay. So that's the history of the electricity. So why we have this one? So the first reason they use electricity was to heat water, and then when they moved to AC, the number is 239. Dulu 240. Of course, American voltage different. I just give you an example lah. Okay. So the technician all biasa dengan 240. Sekarang you bagi number baru 339. Mana kita mau? Tak mau lah. So Tesla said no problem. 339 times 0.707 equal to 240. Okay. So that's how we got our RMS voltage, which is in the middle of nowhere. See here? The meter cannot measure the middle of nowhere here. Okay. The meter can only measure the very top. This 240 is the middle of nowhere. Okay. So so that is our RMS voltage. Okay. The V peak is what the meter measures. So there's a small calculator in the multimeter to convert it to RMS voltage times 0.707. Analog one, you just bend the needle a bit. The needle is supposed to go to 339, but you bend the needle a bit to reach 240. Or you can just adjust you don't need to bend the needle, you can adjust the markings on the, the numbers, you can just adjust it. It's supposed to be 339, but you can put it to 40. Okay. Okay, so that's how we got our RMS voltage. Okay. Okay. So if you look at this, yeah, I did a experiment in UCTS. See, in UCTS in the lab, I put a transformer 20.39, go to a rectifier, come out 18. So it's almost the same. What AC, DC is almost the same. There's a little bit difference. That's because there's voltage drop across the diodes. Okay, normally it's a 0.7 voltage drop across each diode. So you count 0.7 times 3. It's exactly right lah. Okay. Okay. So whatever is AC, that's RMS AC is equivalent to the DC voltage. Okay. Okay. So go back to this. So if you look at this, when the magnet passes one, the red is high. When a magnet passes this one, the blue anti-clockwise is high. When a magnet passes one, yellow clockwise is high. Let me show you again, because I didn't have a pointer. Okay. When magnet passes one, the red is high. Magnet passes this one, the yellow anti-clockwise, sorry, this is blue. Blue anti-clockwise is high, so blue is high at the bottom. And then when it passes this one, yellow clockwise is high. Let's get this one. So this power, you cannot join. You join these two, will be explosion. This will go to Cebu, for example, Cebu induction motor. So exactly when this one is energized in Pitulu, Bakun. This one energized in Bakun, immediately this one will be, this is a motor. Okay, three-phase motor. It will be energized in Cebu. This is Bakun. This one energized in Cebu, this will be energized. This one energized in Bakun, this will be energized in Cebu. This energized in Bakun, this energized in Cebu immediately. Okay, so basically the Bakun and all the motors will turn in synchronism. Okay, serentak. Okay, so that's our current system right now. Okay, so the three-phase induction motor is the best motor because it just follows the generator. Okay, I said follow Bakun, but it's not exactly. But in terms of frequency, it's exactly. They have to make some modification in Bakun because Bakun, the turbine is turning a bit too slow. Okay, so they have to make some adjustment. But if you have a coal power station, it's exactly the same. Like Muka coal and a Cebu induction motor is exactly the same speed. Okay, it will turn exactly the same. Okay, Muka is the power station in Muka is turning exactly 50 hertz. Okay, and your motor, three-phase motor in your factory will be turning exactly 50 hertz also. Okay. Okay. So why just now I told you can join the red, yellow, blue. You see, this one is +1. This is -half, -half. 1 - half, -half, 0. Half + half -1 is 0. 1 - half, -half, 0. Half + half -1, 0. So that's why at every moment of time, every millisecond, you add all three, it is 0. 0 volts. Okay. So that's why it's safer to join 3-phase wires than 2. 2 is a very big explosion, but 3 is not so big. It's just 240, 240, 240. Okay. So you can imagine the power system as Bakun. Power coming out like water rushing out Bakun is going all over Sarawak. What is it heading for? It's not heading for your light, your computer, your laptop. It is heading for Earth, not your house Earth. Your house Earth is not connected to the system. The house Earth is connected to your laptop body. Okay. After your laptop, it goes to neutral wire. What is neutral? Neutral is substation Earth. In the substation, there's a very powerful Earth. Powerful in the sense that in Cebu they normally plant 40 earth rod. Okay, that is your neutral point. So basically, Bakun energy is flowing out, rushing not to your home. It pass by your house and do all the work for you, your factory, and do all the work for factory, but it's rushing for the substation neutral. Okay, because all electricity from lightning to Bakun power, they just love the earth. Why they love the earth? Because earth is SiO2, silicon dioxide. Okay. Okay. So SiO2, Si and O are insulators. Okay. So insulator love extra electrons. You know, oxygen 2 minus, because it loves 2 extra electrons. Every insulator they like to take in extra. Metals they like to throw electrons. That's why Fe 2 plus, copper 2 plus, they like to throw away electrons. Okay. Non-metals like to take in extra. That's why they like the ions of non-metals are minus. Okay, 2 minus, 3 minus, like that. Okay. So that's why all non-metals like silicon and oxygen, they like to take in extra electrons. So the earth, the outer layers of the earth are all SiO2. They love electrons. But if, imagine the earth is a ball of plastic. A ball of plastic will like electrons also, but only the top layer. Because the bottom layer cannot reach the top because it's insulated. Okay? So if the earth is a ball of plastic, lightning strikes, you just make a crater of molten plastic. But SiO2 is partially conductive. Okay, not very much. I mean, like the conductivity of 1 cm cube of copper is micro ohms, whereas SiO2 is like 200 kilo ohms. Okay, but still conductive. That means the will to draw in electrons is not just a top layer. Even the bottom layer also can draw in electrons. Okay, so that's why all electrons in the world just love the earth, and they're all heading for Earth. Lightning will just head for the earth. The whole Bakun energy is just heading for the earth. Okay. Okay, I'll send you all this maybe tonight or something, all these notes. Okay. So that will be your assignment. And the main formula, of course, V equal IR, P equal VI. Okay. Okay. Of course, these are the two main formulas. Okay. The two main formulas for electricity. Okay. And this ohms, because the scientist named Ohm invented this formula. Okay. My father was a World War II soldier. He was fighting the Japanese in Burma. And then later after the war, he joined telecom in Singapore. In Singapore, when he wanted to join telecom, the interviewer, a white man, asked him, okay, what's the formula for electricity? He said, V equal IR. Okay, you got a job. Okay. Till now, you're going to go for electrical jobs, electrical engineer, electrical technician. They ask you what's Ohm's law. You don't know? Okay, reject. Next one. Okay. So everyone must know this formula. You want to work in electrical. Okay, Ohm's law. Okay. And then the three-phase formula for power is what is this? That is okay. So I'll send you all this lah. Okay. I'll show you one more thing. Basically, how you remember it is using two triangles. see there are 6 formulas for power. Okay, so you use 2 triangles. Like me, when I take the score exam, straight away I draw these 2, so I can remember all the formulas straight away. Okay, it is VI, single phase, 3 phase. VI cos, VI sin. VI cos, VI sin. When you go 3 phase, it's root 3 VI. Okay. Root 3 VI cos, root 3 VI sin. Okay. So all these things you put in your assignment, this whole stack of notes. Okay. 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 So okay, now it's already time. See you next week. Okay. Bye.
Thank you, sir.
Okay. Bye.
Thank you, sir. Goodbye.
Bye.
Thank you, sir.
Okay.